Okay, here is an example of a problem where we have a composite shape, meaning it's made up of smaller polygons. We can do that to it. And we're going to try to figure out the total area. Now, if I were a 6th grade student, the easiest way to divide this one up is to make it into 2 triangles. So that's what I'm going to do. I'm going to take my protractor here and kind of use it as a straight edge here to where I can make my triangles. So there you go. Now all I have to do is figure out the values for the bases, the values for the heights, and then I can figure out the area of each of the triangles and then add those 2 areas together. So in this situation, there's a couple ways to do this. I'll show you the easy way, then I'll show you the easier way. The easy way would be to simply count these units straight down. Like I see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I could say it's 11 units, this base is. The easier way to do it is to see that here it's at 7, here it's at -4, 7 here, -4, and add the absolute values. The absolute value of -4 plus the absolute value of 7 is 4 plus 7, which is 11. Now, I'm going to go ahead and write 11 units right here. Now, I have to figure out how high this triangle is. And that's going to be this little point right here, this little line segment I kind of made right here. I could do it the easy way or the easier way. The easy way would just be 1, 2, 3, 4. Say it's 4 units high, or I could see where it's at -5 and at -1 and subtract the absolute values, and that would give me 4. Absolute value of -5, subtract the absolute value of -1. That will give me 5 subtract 1, which equals 4, Madison. So I'm going to go ahead and call this value here 4 units. So my formula for this will be area equals 1/2 base times height. Area equals 1/2. The base I said was 11. The height we said was 4. So area equals 1/2. 11 times 4 is 44. Half of 44 is 22. And the unit of measure is units squared. So that is the area of this triangle. Once I find the area of this triangle, I can add them together and get the area for the total shape. Now when I look here, I can figure out the value of this base the easy way, and then I'm going to show how to find it the easier way. Now the reason I keep saying it like that is a lot of kids find it difficult when they're working with absolute values. Here I could go 1, 2, 3, 4, 5, 6, 7, 8. I could say it's 8 units the base, or I could say the absolute value of 5 plus the absolute value of 3, which is 5 plus 3, which equals 8. So I can call this 8 units. Now the height is going to be from this vertex on down to the base, the perpendicular line here from the vertex to the base. I could go ahead and just say 1, 2, 3, or I could say, well, here it's at -4, here it's at -1. The absolute value of -4 subtract the absolute value of -1 would also give me 3. So this height is 3 units. Now I just have to plug in my formula. Area equals 1/2 base times height. Area equals 1/2. The base is 8. The height is 3. 1/2 times, well, 8 times 3 is 24. Half of 24 is 12 units squared. Now, like I said, all I have to do is add together the area of my first triangle and my second triangle. 22 plus 12 equals 34. So the total area is going to be 34 units squared. Now, I want to point something out. We have no idea what the unit measure is aside from units. When it's not identified for us, like a lot of the times they'll give us inches or millimeters or centimeters, yards, they'll give us some kind of unit of measure. If they don't, then just plug in the generic units square, because anytime you have area, it's like square units that fit inside the surface area of the shape. So that's why we always make a point to do that. Now if I was to attach a math practice to this, I would say I use what I know about finding the area of polygons to deconstruct this complex shape and find the total area. Boys and girls, does anybody have any questions about what we have done here? No questions? How many of you feel like you better understand how to do this type of problem? Okay, I see hands all over. Now, you will be seeing problems like this. All you have to do is just figure out the base and the height after you break it up into simpler polygons, and it's not that hard. Now, Wyatt, do you have a question for me?
Yeah, Mr. Hall. Could you have broken it up into less than four polygons?
Okay, I broke it into 2 polygons.
Huh?
Now, I broke it into 2. I had this big triangle, and I kind of put a little dotted line here to show height. And I broke this, I had this triangle, and I kind of put a line there to a line segment to show the height of it.
I counted that as could you have broken it like straight down from there and made a long trapezoid thing straight down from the corner?
Okay, now wait a second. You mean like from here?
No.
Or do you mean like
Yeah, from there up.
from
Straight.
here up?
Yeah, and down. Yeah.
So, okay, I'm getting what you're saying. So you're suggesting, and let me put this in a different color ink. So let me get this straight. So you're suggesting that I take my marker, we'll say, and I would have this.
Yes, that's
This trapezoid like this, and then this triangle like this, and then this triangle like that.
Yeah, that's how I do it.
I think that that's possible. I mean, you would have the formula for the trapezoid, area equals half the height times base 1 plus base 2. You could do that, and then you'd, yeah, I think you could do that, definitely. Definitely you could have still got the same answer.
Yeah.
What would have happened is you'd have had a smaller area for this triangle, and a smaller area for this, and then you would have this area here. But yes, definitely you could have done it that way. Now, did you wind up with the same answer that I did?
Well, I got confused on some of it and got mixed up, so no.
So you made some simple errors?
Yeah.
Okay. Well, sometimes that happens. All right, any other questions? But that was a good one. When I looked at it, I saw right off the bat 2 triangles. But yes, definitely you could have made a trapezoid, a right triangle, and then another triangle. And that other triangle looks like it might possibly be isosceles.